Good evening, all. This is Jennifer. I'm the host for this session. Welcome to our faculty development program on emerging methods and models in artificial intelligence and machine learning. Throughout the next couple of hours, we will be hearing from two experts in the field who will be sharing their knowledge and insight with us. They will also be answering some of your questions at the end of the session. So please feel free to submit your questions using the question and answer function at any time during the presentation. Before we begin, let me give you a brief introduction about IFERP. Institute for Engineering Research and Publication is on its way to digitalize innovation processes through our professional networking services and thus providing an integral virtual scientific community, mutual engagement, exploring potential of researchers, creating a cooperative and collaborative academic environment. IFERP supports the professional growth of its member by providing opportunities for professional networking, lifelong learning, and career development by organizing scientific conferences, faculty development programs, workshops, webinars, book chapters, seed fundings, special interest groups, research publication, membership, industry institute interactions, etc. Now, coming to the session, before inviting our speakers of the session, Dr. Sapna Katia, to take the spotlight, I would like to give an introduction about her and her expertise. Dr. Sapna Katia has 20 plus years of teaching and industrial experience with leading organizations. Currently working as advertiser at Impledge Technologies, she published and granted 8 Indian, Australian, and South African patents. She issued numerous certificates of appreciations for conducting industry academic conclave trainings FDPs. She has written and published 7 books for UG and PG courses, received Teachers Excellence Award for number of papers and journals and books published by Confederation of Educational Excellence. So without further ado, please join me in welcoming Dr. Sapna Katia to take the session. Dear Dr. Sapna Katia.
Thank you so much, Maria. Thanks so much for such a nice introduction. I'm honored to be a part of this faculty development program. It would be actually my privilege to share my views with the attendees. So I would like to share my screen. Let me first share the screen. I hope it must be visible to you.
Yes, ma'am.
Okay. I cannot start my video. I don't know whether I don't have any like commands or something.
Okay.
Yes.
Yeah, it's okay, ma'am. So you can start the session.
Yes, actually, I'm getting the message you cannot start your video because the host has stopped it. It's okay.
Let me check it, ma'am.
Okay, okay.
Hold on a minute, ma'am. So we are checking.
Okay.
Hello.
Maria, I think I must start the session because the participants are waiting. So whenever there is a the feasibility, just let me know, then I'll open the video.
Kindly check it now, ma'am.
Okay.
Kindly check if you can short the video, ma'am.
Wait. Yes. Thank you. Thank you so much.
Thank you.
Okay. So a very good evening to everyone. As you are aware about the theme of this faculty development program, which is the emerging methods and models in artificial intelligence and machine learning. First, I would like to thank the organizers to pick this budding topic for the faculty development program because the artificial intelligence, machine learning, these are the buzzwords, right? Because every one of us are aware that we are talking about these particular things only, right? So what I thought I must tell you, because you must be having the brief idea about the artificial intelligence, what is artificial intelligence, what it can do. So I thought I must tell you something about the new field, emerging field, which actually has drawn the attention of researchers, academicians. That is actually the aquaculture. So I will be talking about the rise of artificial intelligence in aquaculture. Why artificial intelligence is to be implemented? What is actually the aquaculture is? So this particular session I've designed in a manner that I will be telling you about the aquaculture, artificial intelligence, the background you are aware, and then I'll tell you how you can integrate, means how AI techniques can be applied in which particular field of the aquaculture. So that is what I'll be telling it to you. So this is the agenda. As I've told you, I will be telling you about what is AI aquaculture, what are the areas of aquaculture, why we are talking, whether there is a demand or it is actually the subsidized topic, right? Why we are talking means why the researchers are putting so much of efforts in the aquaculture fields. If yes, definitely there must be certain startups. So where actually India stands and how these technologies are actually changing and the different use cases. So about AI and aquaculture, see, you know about the artificial intelligence means putting the intelligence in a best way so that any system can learn and can utilize the experience on the basis of the functions on the basis of the previous experience. So AI technology, that is actually a very key factor. Wherever you see around yourself, means in each and every field, in each and every area, you can see there is an involvement. Means you must think about robotics, you can think about automation, you can think about any other field, even if you're talking about healthcare sector, finance sector, every sector. Everywhere is what there is a requirement to improve the thinking capability, to make the system efficient. And roughly around 50 billions of the devices we can find in around the world which are actually connected with the IoT. And many of these devices are actually the part of the AI devices also. So you are aware that artificial intelligence can be applied in each and every sector. Therefore, aquaculture or fisheries sector, that is one among the major one. Since aquaculture is a rapidly growing sector, as I'm telling it to you, but I'll be telling you with the help of the statistics also, so that you will be able to understand, yes, actually, there is a requirement. There is a requirement for increasing the development, for putting efforts so that a sustainable aquaculture model can be employed, can be developed. So as you are aware that many devices are there, many parameters are there, which is to be connected, which is to be optimized, right? So when you are talking about aquaculture, what are those parameters about which you need to think? There, some of the parameters are related to the feeding, disease diagnosis, some kind of assistance. But what are actually those? So first, let me tell you about the aquaculture. What is this aquaculture? Aquaculture is breeding, rearing, and harvesting of plants and animals in all type of water environments. Means wherever there is a availability of the water, it may be inland water, outland water, in sea, everywhere. Means if you are talking about aquatic plants, aquatic animals, then putting that particular effort in that direction, that is all about the aquaculture. So aquaculture is the farming related to the aquatic organism. Means you talk about the fish, you talk about the other aquatic animals, and farming is how to grow them, how to provide to the users. See what is happening these days. You must also be observing the requirement of seafoods. It has been increased a lot, means around the world, and not only the other countries, even in India also the consumption has been increased a lot. That is why the aquaculture is one of the budding field where the technologies integration has played a major role. Various optimization techniques have been involved, but you must have uh, understood there is a very thin line in between the aquaculture and the other forms of the like aquatic exploitation, or you can say other forms of the agriculture. Even at the international standards, means the international standards who gives the classifications for the industrial, agriculture and aquaculture, both of these have been kept in the separate economic activities. Agriculture and aquaculture, they are into the different domains. So here from this particular picture, you will just have a quick view about which means aquatic plants and animals about which we are going to talk. So when we are saying aquaculture, aquatic animals, plants, and what is actually the requirement? As you are aware that the requirement of seafoods is being increased. So what is going to happen if you talk about the natural sources, right? So from the natural sources, you can take the food, aquatic plants, animals, and since the requirement is going to be increased, so that particular demand will increase. So what will happen in a coming times, it will the situation may be of this particular kind, that the required aquatic food demand to the population cannot be fulfilled, obviously, because naturally the reproduction rate will be slow, but accordingly the requirement is going to be increased as a larger time. It means there is a requirement of something which is to be integrated in the traditional manner, so that in a coming time all the requirements can be fulfilled. At the same time, the overall system can be maintained. So as you can see in the first image, this is a farm. This is the land of the rice. Means you know that in the case of the rice, huge amount of water is being required. And there is a requirement of water which is actually being available. Then only it is going to impact, then only it is going to benefit the health quality of the rice plants. So that particular water can also be utilized. Sometimes there must be certain areas in the sea, in the ponds, in the wherever the water is being accumulated. All those sites can be identified, and those particular sites can be used for the aquaculture. So land-based, inland water, and coastal water, right? Land-based means rice fields, ponds, tanks, raceways, dams, reservoirs, lakes, lagoons. Any type of water can be considered wherever that can be considered for the aquaculture. And depending upon the quality, depending upon the environment, that particular kind of food can be grown. And now what is happening? Because whenever there is a requirement of to identify the area, there are certain terms. Means area, when you are always talking about the aquaculture field, that particular area must also contain, means the area where the water is being available, the supporting structures, maybe some fixed structures, some floating structures. But other than that area, if there is any offices, there is any other facilities, storage facilities for the supply chain management things, which is being available, that will not be the part of the aquaculture. So as you can see, area of aquaculture as per the production facility means where the aquatic plants and animals can be grown. So you can see various images have been shown, pens kinds of images, cages, tanks, raceways, hapas, sweep images. So here pens are fixed images, cages are, these are the floating structures, tanks are some fixed structures, and hapas are some net kind of enclosures which is being like provided in a larger river, sea or something. So tanks, reservoirs, they are fixed structures which is actually being used for developing the aquatic plants and animals. Since pens are fixed, cages are floating, hapas are some this kind of structure where the net enclosures is being provided. So any kind of structure, depending upon the site, what kind of the feasibility is, that could be developed. As I've told you that aquatic food demand is increasing day by day. You are aware that the world population is increasing, right? Every year. And per person world income is also increasing. Because if you see 5 years back, the average salary per person was relatively low. But today, if you compute the average salary per person, it has increased a lot. Similarly, the demand of agri-food, that is also being increased accordingly as the population is increasing. And nowadays, there is so much of the interest and taste of the persons, they are requiring the agri-foods. Right? So it has been observed that the real food, the value that is actually being, if you compute, if we project how it is going to be increased by year 2050, so that is going to be increased approximately 77%. Starting from year 2007. So starting from year 2007 till 2050, 77% means per year approximately 1.3% is increase. Now you can thought about, if there is so much increase in the requirement, then how we are going to fulfill that particular requirement. Definitely technology's intervention is very, very important so that we can move forward from the traditional manners. So from this particular curve in year 2007 and 2050, the projection is being shown, means what kind of the distribution will be in between the vegetables, fruits, meats, cereals, fish, and how it could be. So depending upon the projected score and the previous value, it has been estimated actually. So aquaculture market, you are now, you must be understanding the demand is increasing. But some of you must be thinking that aquaculture means agri-food, seafoods. This is not the requirement a lot in India. No. Nowadays, even as per the statistics, as per the research data, the demand of aquatic food in India is also being increased. Means aquaculture industry is one of the budding industry for the for production, for revenue, means which is going to impact the overall quality. So aquaculture market in India, you can see in year 2050, it was USD 15.4 billion. But in 2025, it is to be projected by USD 26.29 billions. Means there is a compound annual growth rate of 10% in between that. Similarly, if you see the global aquaculture market, so you can see there is a huge requirement in next 10 years from year 2020 to 2030. It means aquaculture products, they are very, very required because the people are now aware that they are the good source of the proteins for nutrition replements, right? So for the means they are focusing a lot. And aquaculture, this is now a very important activity in many countries. So now since aquaculture is very, very important activity in many countries, it means definitely there is to be something which is to be done from the technological point of view. Let me tell you, the top 5 startups, aquaculture startups. This is actually the data which is being collected in a global startup heat map, which was held in US in March 2022. So many startups have applied from the same field, and top 5 aquaculture startups have been identified. And you must be wonder that among top 5, one company, one startup is from India also, which is the AquaConnect Smart Aquaculture. And this particular startup, it was founded in year 2017 and it is based in Chennai. So now you can see how India is also contributing, how ahead the India is also in this particular field. Means aquaculture industry is now the interest of many enterprises, many organizations. They are exploring how they are going to replenish the aqua foods, aquatic foods, and how they are going to convert that particular requirement. So they are going to fulfill, and finally, definitely they are going to impact the revenue. So as you are aware about the background about the aquaculture, now let me tell you where actually the requirement of technology is. If you are saying AI ML is being required, IoT is to be integrated, then what are those particular factors? What are those portions where it could be? See, definitely with the integration of budding technologies, innovations, the things, the efficiencies to be improved, and that is actually going to benefit a larger audience, a larger users. And definitely with the help of the integration of technology, aquaculture will also be a like pointer field which is going to significantly contribute in the world economy. So here you can see a diagram in the upper half that is about the traditional. What is to be done if you're talking about the aquaculture, means aquatic foods, aquatic plants, aquatic animals, there must be some site. Site may be a small scale, site may be a large scale. So whatever the nature of site, if that is not available, then definitely we have to recreate. This is what we are talking about, the traditional manner. Recreation means we will be looking for those particular sites where the water is available, where there the favorable environment is. So either the sites will be available or we have to recreate, and accordingly whatever the things, whatever the requirement is, whatever the available space in a coming time which is to be done, each and every record is to be maintained on a paper. So what is being happening? Suppose there are 10 sites, so every record is to be maintained, data is to be collected from each and every site time to time. Then there would be a center place where all the sites data is to be recorded. Maybe there may be a manual requirement so that time to time indications, time to time reminders can be set. Now this is the time to check the water quality. This is the time to feed the fishes. This is the time to check the health of the fishes. So some kind of manual things or reminders may be set time to times, and there may be that particular data may be utilized by the scientific body. That data can be utilized by some management agencies for supply chain building blocks, and all those agencies may be sharing the data. Suppose some particular data is to be taken for the scientific purpose. So whatever the extraction data is to be analyzed, if required, that data can be sent to the supply chain department, the other management agencies for well-being or for something that is to be done. So this is actually what the traditional way of doing the farming. Farming means which we are talking about the agri-food. And this entire process, this is of around year or more than a year. Means what is to be done? If you talk about in a step-by manner, so you need to collect the data, then data is to be delivered, data is to be stored at a central place so that it can be accessed by each and every one. Whatever the data is being collected, that data must be analyzed so that necessary things can be taken out. So that from the data extraction, whatever the kind of decision that is to be taken out. So this is what actually the traditional way of doing. But what is happening by integrating the cloud, by integrating artificial intelligence, whatever the means, by integrating IoT sensors, so all the sites data can be monitored, can be collected in a real time, that can be updated. so that that particular data can be observed, that particular data can be utilized for many purposes. No need to visit to the site again and again, each and everything. What is the size of fish? Suppose we are talking about fisheries. What is the size of fish? Whether there is a requirement to provide the feed to the fishes? What is the, like, how many fishes are available? What is the water quality? Means what is to be done if there is a dirty water, some like some of the things is being found which is not being favorable for the fishes. If there is any weed, something, what is to be done? So you can see every real-time data can be accessed, and that data can be processed accordingly, the required things. From the extraction, if required, the alerts can be given to the scientific body. If required, the alerts can be given to the supply chain. Now, this is the time to take out the fishes from the ponds, and it is available for the supply. So accordingly, by integrating technologies with high-tech system, the entire process can be completed sometimes within a days, within a weeks, or within a months, depending upon the nature of the site, which kind of site is actually. What is the size of the site actually. So as you are aware how it is to be integrated, since if you talk about the data drive intelligence, right, for fish farming only, what is being happening? Fish is an object. Fish is like available fish is surviving in the surrounding of environment, means there must be availability of the water, otherwise fish is not going to survive. And for that, there must be requirement of some equipments. Equipments may be inland equipments, or some equipments may be kept outside. So what is to be done? For that particular object, for those fishes, they needs to be monitored. Sometimes decision making is to be done, whether they are healthy or not. If they are not healthy, what is to be done? If the water quality is not fine, what is to be done? Control, even the reproduction rates also, that could be controlled. Management, analysis, prediction, means prediction about the disease, prediction about the health quality, prediction about the what could be the developed size of the fishes, means what could be the length, what could be their weight. Each and everything can be managed. So what is happening with the help of the, by integrating artificial intelligence, the overall system cost can be reduced. Obviously, so many manpowers are not being required, cost can be reduced, output will be high, increase, and definitely the system would be the efficient system. And overall, there would be an improved quality, because at each and every time you are getting the updates about the object. If the object are the aquatic plants, even for those plants also, you can identify what is the size of the leaf, what is the color of that, whether it is healthy or not, if there is any weed available nearby. So that particular weed need to be extracted, and accordingly, there is necessary decision. So definitely it is going to impact the improve the quality, and overall system would be very, very efficient. So when you are talking about the plants and other objects, aquatic animals which are available in the water, usually the machine vision or the computer vision, that is actually the major tool. Means with the help of the camera, images is to be taken, that particular those images is to be processed, and then accordingly those images is to be analyzed, and from that the necessary extraction can be done about the information. Why these kinds of things is not available in the traditional manner. So now you can see how artificial intelligence is contributing. Means artificial intelligence can contribute for each and every damn thing. If you talk about only the fish, it could be applied for fish length observation. If you are saying this length of the fish that is healthy, that could be extracted. This length of the fish need not to be extracted. Let it be in the water. Let it be grown. Fish width, what is the height, what is the weight, even the different kinds of fishes, if they are available in the same water, their classification, and each and every fish which is having a different, like uh, you can say from the different class, every damn data could be collected. For those particular things, disease identification, disease prevention, What is the required time? There is like probability, possibility of something can happen to the plants and something can happen to the other objects. So that could be determined. Accordingly, necessary action can be taken. Even if there is a lot, if there is some site in the sea. So counting can also be done. What is the total count? If these many objects have been extracted, what is the remaining one? Whether it is going to fulfill the demand or not. If not, then we have to focus for the other side. So you can now think about each and every type where artificial intelligence can contribute to the aquaculture and fisheries. Here you can see the three verticals have been shown. One vertical is about the data collection, communication. Definitely, data is to be collected from with the help of the camera, some satellites images is to be taken, some portable device may be there, some kind of sensor networks, IoT, some underwater drones, right? So any kind of these kinds of the things actually available, and via which data collection can be done very easily. Communication can be held very effectively. Then whatever the data is to be collected, that needs to be processed. Data can process, and there are many tools, many algorithm. Accordingly, the data can be processed. And from that particular data, certain models, certain techniques can also be validated. And after all, whatever the data we are getting from that, different actions can be taken. Means which particular zone is the heavy dense zone from where we can extract the things. Which particular zone means we need not to focus now because there is a less availability. Let us focus to grow the system, right? What is the actually side which is going to means which is the healthier one? Which particular site will give you the best possible food depending upon the surrounding environment, surrounding facilities and all. So this is actually all about means how it could be integrated. Now you can think how cloud computing, IoT, AI, ML could be implemented, and how the algorithms can be developed so that we can find out whatever the data we need we would be able to extract. Let me give you some examples how AI is changing aquaculture. One is the overfishing. See, overfishing is what? If you can see the beginning population and you are extracting more and more fishes, more and more plants, what is going to happen in a coming time? The quantity of those particular plants or those will be reduced. So what is happening? Overfishing can be avoided with the help of AI, with the help of integration of artificial intelligence. Because impact of overfishing in a longer term, that would be the means if natural selection is not being that is being done, and we are picking quickly, immediately those particular fishes, then the size of the fishes will be reduced. And sometimes after a certain time, we may find that very less fish is available in the ocean, which is not going to fulfill the requirement. While artificial intelligence can fulfill, can means you'll be getting everything, every information you'll be getting, so that now you'll be thinking that this is the time to stop the extraction from this water so that it could be regrown further. Second is the precision fishing. Precision is all about observing, measuring, and responding. As you are aware that world's population is increasing, and it is to be increased approximately 20% by year 2030. This is, I'm talking about the world. So precision means which kind of tools are required so that you can accurately monitor the fish stocks in real time, so that when you are monitoring the fish stocks, aquatic plants in a real time, and you can catch the right plant, right fish. Catching, that is also very important, because if you are picking any wrong fish or wrong plants, that is going to provide you loss. So it means picking the right plants, right animals, right? And accordingly, what kind of ecosystem is to be maintained. So observe for better understanding about what is to be done, when it is to be done, what is the appropriate time, at the same time measuring the variations. If you are picking the plants one by one, what are the variations, what are the remaining things, and how it is going to impact the environment, means optimizing those particular forces. Artificial intelligence and IoT devices, definitely IoT sensors, IoT devices can be placed so that the real-time data can be gathered, and those particular data are actually very helpful in wild fishing industry, because that real-time data is going to provide a reduction in the cost. Because in the case of the aquaculture, a lots of cost is being involved for the site, a lot of cost is being involved in the traditional manner where the manual intervention is being provided. Next is the health and welfare. Health and welfare means means getting every relevant data about the aquatic plants, aquatic animals, health data. What kind of food is to be given, when the food is to be provided to the fishes. See, what is being happening, ensuring health and welfare, that is actually going to impact the overall aquaculture, because fish, plants, they are available in the water, they are growing in the water. Even if a dirty one drop of water, that is going to impact the health of all animals and plants, right? It means maintaining water quality, that is also very, very important. Any kind of weeds, any kinds of other germs or anything, that is to be extracted, that is to be deleted, which is very difficult in the case of the traditional intervention, because in the case of the traditional, whatever we are getting, that is actually to be provided. So when there is a requirement to clean the ponds, when there is a requirement to prevent from the disease, what are the possibilities? Accordingly, the necessary actions can be taken. Feeding optimization. See, you can see actions means fish growth, fish health, and feeding cost. Feeding cost is very, very important factor which contributes in the total cost of the aquaculture. Feeding cost, this is very high. What is being happened, some of you must have seen at your homes also, if you have seen the fishes. So what is to be done, there are some dry pets which is to be given to the fishes, and after certain time, after a week or 15 days, you need to clean that aquarium, because you find that now the water is dirty, it is not good for the fishes. So now you can think about a large sea, where if additional quantity of this feeding, feds, diets that is being provided, that is going to impact the entire water quality. It means since feeding takes a large portion of the operating cost, its cost is also high, and excess quantity of feed to the plants and fishes, that is going to impact the water quality. It means what is our requirement to find out the appropriate quantity, appropriate time. That is only possible with the help of the artificial intelligence and other technologies, of course. So now you must be aware that each and everything, whether you talk about health and welfare, whether you talk about the feeding optimization, each and every point, each and every you can say the point is giving you an idea where artificial intelligence is going to be integrated. Harvest enhancement, definitely for enhancing, for improving the harvest quality, quantity, reproduction, growth, everything. There is a artificial intelligence can be integrated. What is the appropriate time for the reproduction? What is the appropriate rate? Which kind of models could be used? What kind of supporting environment? And everything can be observed. Since I've told you that artificial intelligence and IoT, these are actually the budding fields where it can be, where means they have bring actually a blue revolution, I must say, blue revolution in the industry. So even in 2022, here some of the screenshots I have listed out, which is the most popular tools regarding the IoT. So you can see how AI and IoT that are going to contribute for the healthcare, for aquaculture. So many things are there, and aquaculture is one of the promising field among which it could be applied easily. So these are two use cases. Means I'm just telling you what are these two use cases. But before this, let me tell you what I have told you, that AI can be used in multiple ways in aquaculture. And one of the significant application is in monitoring and controlling water quality. AI measures parameters of water, like what is the temperature, what is the dissolved oxygen, what is the pH level of the water, so that that particular data can be used in optimizing feeding, reduce wastage, and prevent disease outbreaks. Another thing, if we are talking about fish health management, I have told you about the fish health management, means AI algorithms can analyze fish images, detect if there is any sign of the disease or injury, allowing farmers to take necessary actions before the condition becomes more serious. Means every real-time data is to be extracted. So AI can also be used for tracking, for monitoring the growth of the fishes and predict when they are ready for the harvesting. So AI is also being used to improve the efficiency of the feed management, so that by analyzing data on fish behaviors, feeding patterns, environmental conditions, AI algorithm can optimize feeding schedules. Feeding schedules can also be optimized so that water quality can be maintained. Feeding schedules means if required, the feed is to be provided after 15 days. And after 15 days, if it is being find out that no, there is no requirement, so that could be delayed by a day or two and accordingly. Right. So that is what I have discussed about the various factors. Now let us talk about these two use cases. Here, first you can see smart cage culture management system. Smart cage culture management system means cage culture is a means there is a kind of pond which is to be managed. So what is happening? IoT sensors have been deployed over there. AI algorithms for optimizing the thing, means AI algorithm is being applied for intelligent feeding systems, fish behavior monitoring, analysis, smart reason of view, means in which, but in that particular larger sea, what is our required view, where we are actually incorporating, where we are actually observing. There are some unmanned aerial vehicles is being also implemented. And since there are many sites, data related to each and every factor, even related to the water quality, we may be getting 10, 15 kinds of data, temperature, oxygen level, CO2 level, pH quality, depending upon the fish, for related to one category of fish, the like different kinds of data we must be getting over here. So now you can assume, you can understand how broad quantity of data we have to process. Definitely the big data is being like that is to be required, because all those particular data needs to be analyzed. There must be some data centers. So in this particular manner, smart cage culture management system could be implemented. So as I've given you the various factors about the water, temperature, humidity, carbon dioxide, pH level, what is the ammonia level, light intensity, COD, nitrite, water. So many factors could be considered, and actually they are going to impact for increasing efficiency, reducing cost, everything could be handled. Second is the intelligent fish farm. This is actually a IoT ecosystem which is being developed by some of the researchers. So now you can see, you can have a overall view, overall like idea in which particular manner it is to be like implemented. Means some of the sensors related to the finding accurate value, real-time value about the temperature, ammonia, pH level, what kind of the feeding machines, what kind of the other actuators, if there are some underwater vehicles, some kind of drones or something, unmanned boat. So all these things can be implemented. And with the help of the like devices, we can gather the data can be embedded somewhere, data can be stored on a central server, and accordingly it could be processed, so that with the help of that gathered data, we can perform so many actions related to the um, quality feeding, intelligent feeding, what kind of water quality control can be taken, different fish behaviors analysis could be done, biomass statistics, disease diagnosis, equipment operation monitoring. So everything can be handled. So just you think about the individual task, any task you think that is possible with the help of the integration of the artificial intelligence, because artificial intelligence has like the capability, depending upon the past experience, depending upon the exercises. So the massive data which is being provided by many servers can be analyzed, and it will always gives you the optimized value, but will always helps for the decision making, will always helps for the efficient manner in which the entire ecosystem can be handled. If you compare artificial intelligence with the other traditional technologies, then it provides you the intelligence for quick calculation, quick processing, very fast analysis can be done. It helps for the predictions, problem planning, even for the complex problem solutions can be identified. Even if you would like to think upon, suppose there are 5 ponds, right? 5 aquaculture sites, and from those particular aquaculture sites, if you have to extract the aquatic plants and animals, so with the help of the artificial intelligence, you will be getting the things, means in which manner, which particular site is to be serviced first, then which is the second site which is to be serviced, and accordingly how the supply chain is to be managed. What is the life of the fish, and what is the health, if we are talking about today. So today, in which particular site, what is the health parameter? What is the size of the plants and fishes so that it can be extracted next time? So even the artificial intelligence helps to optimize the selection of the sites in an efficient manner so that the plants and things can be extracted. Along with the artificial intelligence, as I've given you many examples about the IoT, edge computing, 5G, big data, right? So these many like technologies, they are actually complementing the artificial intelligence, and they can be integrated so that a wide technical supports can be provided about which we are looking for, so that whatever the requirement is going to be increased within India or at the world level, and that requirement can be fulfilled. And accordingly, definitely, this development is impacting a lot in the revenue at the worldwide level. So what I've told you in overall, let me conclude you that the artificial intelligence, that is actually increasing their involvement, and the interest of the researchers, academicians, and other professionals is also being increased in the area of aquaculture, because it has the potential to make fish farming more efficient, more accurate, sustainable, and profitable, of course. Until unless it is not going to impact the revenue, it has no meaning. So by improving the various things about which I've talked about, water quality, disease reduction, disease outbreaks, even optimizing feed management, AI can help uh, the industrialists, the organizations, to produce more and more food with less wastage and with less environmental impacts. So that is how the interest of integrating artificial intelligence into the aquaculture is being increased. That is how it is going to impact at a sustainable level for worldwide. So this is all from my end. Thank you so much for listening very patiently. If you have any question, you can discuss with me. I hope in this particular session, I am able to give you a brief idea about what is aquaculture, And what are the various factors upon which you can think about integrating artificial intelligence? And along with the artificial intelligence, what are the other complementary techniques which could be implemented? So my objective was to give you a glimpse about this. Thank you so much. Thanks, Maria. I think I'm done from my end. If there is anything we can discuss.
Ma'am. So thank you, ma'am, for your wonderful session. Dear participants, if you have any other questions, please let us know in the chat box. Thank you, ma'am.
Thank you. Thank you so much.
Dear participants, within a few minutes, we can start the next session. Dear participants, kindly wait for 5 minutes. Speaker will join within 5 minutes.
Hey, hi everyone. Hi Karthik.
Hi, sir.
Yeah, sorry for being late. I was occupied with some work.
Yeah, it's okay, sir.
Should I start?
Wait a minute, sir. Dear participants, thank you for your patience. Now I would like to welcome Mr. Sadaq Hussain. Mr. Sadaq Hussain, working as a senior associate LOP at the Mac company, and he was one of the managing partners for the Quantum Computing India community. Formerly worked as a developer advocate at the London Stock Exchange Group. He was having 5+ years of experience in analytics and building end-to-end ML pipelines on the cloud. Published a few research papers at national and international conferences. His current research investigators was about use cases of quantum computing in finance and healthcare. Also, he was specialization in data science, machine learning, Python, SQL, neural networks, artificial intelligence, innovator, researcher, quantum machine learning. Dear sir, you can start the session now.
Thanks, Bharya, for the introduction. So, hi everyone. Thanks for joining the session late evening after a very long day. So I will try to keep it short and to the point. I'm going to share my screen. Let me know if it's visible to you. And then we will start. I hope you can see my screen, right? Mario, Karthik, can you confirm if you can see the screen? Great. All right. Hi everyone. I will be talking about ML ops today. You'd have seen a lot of AI and ML use cases, models, and you'll be seeing in the upcoming days as well. But when we work in the production, how we can build ML pipeline, log artifacts, metadata. We can take how we can take care of security of the pipeline, automation of the complete end-to-end pipeline, versioning, scalability, reproducibility. Those are the certain pain points and challenges which are there in the industry based on use cases to use cases and how those can be solved. I will be discussing more towards that and not going towards any of the algorithm side, basically. Okay, so how a good, robust enough ML system can be designed, what are the things we need to take care of and all, we will be discussing during this session. Okay, so to start with, Maya has already given my brief intro, but just to give you a brief about myself. Like I worked as a senior associate at MLOps at the math company. I lead the MLOps capabilities over there. And I'm AWS certified machine learning. Like I've done professional ML certification as well. And I'm a builder. Apart from that, I'm also authoring a book titled as Financial Modeling Using Quantum Computers, which is live for pre-sale on Amazon. That's pretty much about me. And if you want to connect with me on any of the channels, this is my LinkedIn handle. You can approach me over there. If you have any questions, queries, anything you want to discuss, feel free to ping me. Okay. So this will be like a sort of rough agenda. I will say we will first try to understand what is MLOps, why do we need it, what problem can be tackled using MLOps methodology. Okay, We will go through some sample architecture and we will have a demo after that. So I don't know how many, can I get yes or no, like how many of you are working or have tried deploying any of the ML models in production, or you have faced any challenges while working with it? Or do you have any idea of this, like how long it takes for an organization to deploy a model if there's a change in the code? Anyone? Okay, so typically, like it's fine if you are not aware of that. So typically, it can take a lot of time, and if even a small change is happening in the code, right, to make sure everything is in line and nothing is breaking up and all, right, it takes a good amount of time. So it can take few days to a week to validate all the changes or the impact of the change on overall pipeline or the code. That is one thing. Okay. Apart from that, if a model has been trained and deployed in the production, right, it becomes quite difficult as well. Like, yeah, basically real-time changes takes more time and definitely complexities will be more. Shiv Kumar so has answered that. And also once the model has been trained, right, it's not like once the model has been trained, it will be giving us the efficient prediction always. The performance of the model also gradually decreases over time, right? Might be the data on which the model has been trained is slowly shifting towards some new dimension, right? Then the obviously with the new upcoming data, when we'll try to get the prediction, since the ML model is not up to date or has not learned from the recent data, the prediction will also be the junk in that case. So the concept of model decay is considered as the concept drift, like how with the new upcoming inferencing data. So I will be interchanging the term inferencing data or prediction data. Both of them are the same. So how with these new inferencing data, the performance of the model is getting changed in the production, right? So people know about this concept, but how to incorporate that in ML pipeline, which is in the production, is the major challenge, and how to monitor this at the scale and all, how to set up the alert, how to decide the threshold on which column, on which metric we should set those threshold and all, is another important aspect of the ML pipeline. At any point, if you have any questions, any thought, please feel free to ping in the chat. I will be happy to take that up. Okay. Next, once we have all these done, right? Yeah, I mean, can we, I mean, whatever experimentation we do, most of the time you would have seen the experimentation starts with the Jupyter notebook and ends up in the Jupyter notebook, right? We will be loading the data, we'll be doing some EDA, train the model, save the model, make the prediction, save the data. That's it. We are done. But again, when it comes to real-time ML pipeline deployment, right? Can we really build, test, and like train this model in a repeatable, reliable, and automated way? Is still, if you see in ML pipelines in the production, right, there's a lot of human intervention involved for testing the model, for experimentation, for uh, like for manual approval, there are certain things. So I'm not saying like everything needs to be automated completely. Obviously, when a model or when a pipeline is going into production, there should be some manual approval and human intervention over there, but that should be limited to understand what output we are getting, and based on that output, if any anomalies has been detected or if any threshold criteria has not been met, in that case, what action needs to be taken care of, that can remain with the human, but rest all part can be easily automated And if we have written proper test cases and all, if we have packaged the code in an appropriate way, right, then we can rely on this. And just to talk about certain scenarios, I don't know like how many of you have worked this way. So many times you start working on a use case, you keep on creating new version of the notebooks, right? How easy it's for you to track and observe the changes. Let's say 1 week back, I used this. What was the result of that and all of a particular experiment? I used random forest algorithm or XGBoost algorithm. What was my result and metric? What was the data I used? What are the features did I use for training that ML model? So the complete pipeline and reproducibility also becomes a very challenging part over there. We don't have proper version of the data. We don't have proper version of the code. We don't have the everything like properly logged deep metadata, model parameters, output of the model, artifacts being generated, any EDA plots or graphs or stats you're generating, right? People usually don't log all this stuff. They just experiment and play around the notebook and deploy the pipeline in the production. But once the pipeline is in production, you have to trace back anything or you have to reproduce anything, any of these things. It becomes a very challenging for the data scientist or whichever person is working on that project. To overcome that and to make the ML pipeline more reliable, more automated, and more repeatable, we have ML Ops. So ML Ops basically stands for machine learning operations. And it helps the organization in creating or improvising the ML pipeline deployment or whatever CI/CD pipeline we designed or developed for putting these ML projects in production, right? It helps in improvising that, and it automates the infrastructure part as well, so that the operationalization time from development, from experimentation to development to QA environment to production can be reduced. Okay, so this is like one of the rough diagram. Like if you see, I have taken the example of AWS over here. So just to give you a brief about this, like how this is not the complete ML pipeline. Each of these components will be expanded further. So as a data scientist, let's say if you're working on AWS, then SageMaker is the IDE where you will be doing the experimentation, you'll be building the model or training the model and all. AWS Code Commit act as the assets repository where you save your code or model assets, whatever you have. Code pipeline is your CI/CD pipeline, which is responsible for running your code from one environment to another environment. So environment management is also very important when you work in the production. So you can't make changes in the production environment. I hope many of you would be aware of that. So when you're working on some real-time project for the client, for your organization, right, in that case, most of the time you will be working on development branch or feature branch. If you follow proper Git practices, then once you are sure that this feature has been developed, this part has been coded properly, then you merge that to the QA branch. And in QA branch, the whole pipeline will be automatically running. And if all the test cases, all the checks will be passed, then the code from the QA branch will be merged to the production branch. And once the model has been trained and all, then we have training or inferencing container. So training container will be responsible for training the model, and inferencing container will be responsible for the prediction by loading the whatever model output we have from the training, right, for the incoming data. So this is a rough architecture. Let me take you through this actually. Before going to this, right? So I want you to walk through an article which I wrote some time back. Okay. So version controlling, testing, automation, continuous monitoring, and all we have already talked about. So if you see this diagram, right? I'm zooming up. I hope you all can see this. So this is how your complete ML pipeline looks like, okay? So it's not just loading the data in the Jupyter Notebook environment, training or trying out some different machine learning algorithm or deep learning algorithm and dumping the model and making the prediction. That's it. Our job doesn't end over there. So how it gets started with, whenever you will be working on certain project, right, you will have a development environment, you will have a staging environment or production environment, okay? So in development environment, so very first we need the data, right? Data can come from multiple sources. So this data catalog acts as a data source, which goes for experimentation phase and for production phase both. So the source for data catalog can be anything. It can be Snowflake, it can be any relational database, it can be flat files, right? It can be Parquet files and all, Excel files, whatever data source is there. The data pipeline will be responsible for that, to collect the data from different sources and transform that in the required format. And from here, whichever data scientist is working on a particular project, they will be using this as a data source. They will do the data assessment. They will try to analyze the data. They will pre-process the data, right? Whatever pre-processing steps are being needed. And they will do certain sort of feature engineering, and they will train some model. Obviously, you cannot just directly go with one model, right? A lot of experimentation is also needed to make sure the model which you are choosing for your use case is giving you the reliable results, right? So doing the model analysis and all. Once you're done with this step, with the experimentation step, this will be an iterative step. You will have a code repository where you will be like making changes in the code and updating, so that your code is in sync. So we go for Git here, right? GitHub, GitLab, Bitbucket, and all are the different code versioning tools which you can utilize in that. So you will have source code repository. For your code, there will be certain test cases like unit tests, integration test, smoke test, right? The different type of testings which needs to be performed. Earlier, people were just performing these kind of tests in software engineering, but in machine learning also, in ML space also, we need these kind of certain tests and checks needs to be performed before to make the code more reliable and so that it can be reused further. Okay. So these tests will be happening. You will have a test case files and all, and you will be building the CI/CD pipeline. So once you're done with these experimentation phase, you will be pushing your code to the staging stage, and here's a smoke test and all will be performed. And based on the test report, whatever you'll be getting right, you will decide whether you want to roll back the changes or you want to merge that changes to the production branch. Okay, at the staging stage, basically pipeline deployed to staging will be there, the code, and certain tests will be happening. Before moving forward, anyone is having any questions? Okay, I don't see anything in the chat, so I will be continuing forward. Okay, so once we have the code in the production, then in production, we automate the complete pipeline. So our level of automation can be decided by the organization goal and the kind of project you are working. In each project, we don't need to automate each and everything. Okay. So based on that, you will have alert mechanism, as I said. So the different checks which we can perform. Others can also not see the diagram. Mario, Karthik, can any one of you confirm?
Yeah, yes, sir.
It's visible, right?
Yes, it's visible.
Okay. So anyway, I've shared the LinkedIn article link. Please, you can refer that directly on your screen as well if you want.
Your screen is visible and the diagram is also visible.
Thanks for the confirmation. Okay, so once the code is in production, so there are different type of checks and alert mechanism which needs to be incorporated in the ML pipeline. Very first, once you load the data, right, data needs to be checked. If data itself is not correct, right, obviously the model trained will not give you the desired results. So each incoming or each new data, whatever you're getting from the this data catalog, right, there are chances that uh, some anomalies can be there, some extra nulls can be there, some missing values can be there, right? So data quality framework, like companies make use of data quality framework where they define all their checks and conditions which needs to be performed on the incoming data, so that, and a report gets generated for that, so that they're very much sure whether the data which they are using for model training and for the experimentation is aligning and it doesn't have any anomalies over there. Okay, so this is the first step of alert and quality check and all. So talking about the model pipeline, right? So all these pipeline steps will be automated, be data extraction, data quality check and validation, which I was talking about, pre-processing, model training and tuning. Then we validate the trained model as well, and we evaluate that model. Based on the evaluation, if that model will be meeting the criteria, then only we save all these. We will be saving all these pipeline model metadata in model metadata store over here, and we will be logging the pipeline logs as well, like system level logs. And in the model registry, we will be saving the model where the model versioning will be taken care of, right? So data versioning gets taken care of at this level, at data catalog level. Here you can implement the feature restore as well. Feature restore I have not mentioned in this diagram, but feature restore is also important component of the MLOps. Code is versioned and maintained in the code repository. Model is maintained and versioned in the model registry. Logs and all we will have for debugging any issues or any error in the pipeline, right? Each time it's not very much 100% guaranteed, right? The pipeline will run very smoothly and will give all the results. And we will have monitoring dashboard where we will monitor for data drift, model drift, feature attribution. Feature attribution is considered as the explainable AI to understand how the features which we have selected for training the model is contributing towards the end prediction. Is there any changes in that contribution? Is there any drift being detected, right? So all those things needs to be monitored. And we will have alert mechanism on top of that. So if at any point, any of the threshold or criteria will not be met for data quality check or for the monitoring component like data drift, concept drift, and feature attribution, in that case, the alert will be triggered. To trigger the automated pipeline, once the code gets merged from dev or QA from that, this will be happening. And data drift component and model performance monitoring, you can see you will have a dashboard. If anything, any anomalies will be detected, alert will be sent to the relevant stakeholder through email, through team, or through Slack channels, like whatever mode of communication they opt for. And model serving also, once a model has
Hello.
uh,
Yeah, hello, sir. Your screen is not visible.
prediction and offline prediction both. So based on if there's online prediction, obviously you would have to take care of scalability as well. So you can use load balancer and all to define what is the minimum number of instances, what is the maximum number of instances you want to use based on the load you will be getting on the endpoint. Okay. And once the prediction has been done, it will be dumped to the predicted data store, from where the decision makers or stakeholders can consume via dashboard or application. So this is a rough outline of MLOps architecture. Obviously, there are certain missing components like feature store and all I have not mentioned. And few of the things are at very high level. But just to understand, you can think of this diagram. The different architecture being given by Google, Amazon, Microsoft and all, which you can go and search. So the agenda of this session is just to make you aware of ML ops, what it is, what are the different components which you need to take care of, and what are the different challenges in this, right? So if I talk about challenges, then reproducibility, performance monitoring, right? Tracking any trade-offs, and uh, bringing together different team with different kind of bringing together a team with different kinds of specialization, right? Securing a model security. These all are the certain challenges which people face. And then compliance and regulation issues. These are also a few of the things. One more thing I wanted to discuss here is like, how do you identify what level of maturity you are in based on your ML pipeline, right? So this is the this we have taken different references, and based on that we created this diagram. So like if nothing has been automated, right, you can see these checkbox over here, like what is the level of maturity for the ML pipeline. Based on that, you can decide like what all you're doing and where you stand in the maturity terms. So if none of these ways of working are being followed, then there's no ML ops. If you have automated way of data extraction, end-to-end data pipeline, testing for data pipeline, and versioning, build and versioning for the pipeline, then you are like using DevOps in your ML pipeline. That is called as DevOps with no ML ops, and that is considered as the level 1. On top of this level 1, if you are doing experiment tracking using the tools like MLflow or Neptune.ai or Weight and Bias, you have automated the way of model scoring and versioning, and you are managing the model compute as well. Then you can think your organization at level 2, where you have automated the model orchestration process. Beyond that, if you're going like model release by using the CI/CD, you have the feature restore implemented and model monitoring implemented, then you are level 3, where this is considered as the automated model deployment. And if you have retraining triggers and all, obviously model needs to be re-triggered also, right? Based on the performance degradation and the new upcoming data, whatever cadence you choose for training your model pipeline. So if you have retraining triggers and all as well incorporated in your ML pipeline, then that will be considered as the full ML ops automated training. Obviously, different organization will have different set of standards, but this is again just to give you an overview of like where your organization is stand or where you stand in terms of following the ML ops practices, like in terms of maturity level. Okay, so this was pretty much about me. I wanted to keep it short and to the point. I will take up the questions and will try to answer whatever I can. Feel free to unmute yourself and ask the questions, if any.
Dear participants, if you have any questions, please let us know your questions in the chat box.
So just to add on a few more things, like you can think this MLOps architecture, ML pipeline as designing the ML system. So far, we have been designing software systems, right? System design you would have heard of. So MLOps is a way how you can design the systems for ML pipeline. Like if in short words we talk. Okay, so this is pretty much from me. Yeah, any questions now? And it has certain other components as well, like resource optimization, cost monitoring, cost optimization, and all. So these all goes in the monitoring component, which helps you in utilizing your cloud resources and optimizing the cost and all more efficiently, so that you don't spend $100 for the work which can be just done in $5 or $10, like that. So resource monitoring and cost optimization is also like one of the important aspects of this. Yeah. Okay. I don't think they have any questions, Mariam, right now.
Yeah, okay, sir. So we can wind up the session.
Yeah.
Okay. So thank you, sir, for the fabulous session.
Thanks, Maria, for the opportunity, and sorry for being delayed and keeping it
Yeah,
short. I have certain things.
At the end of our event, I would like to take a moment to express my gratitude to all of you for joining us today. I would like to start by thanking our distinguished experts, Dr. Sapna Katiyar and Mr. Sadaf Hussain, for taking their time to share their expertise and insight with us. Our presentation was engaging, informative, and thought provoking, and we all learned a great deal from your experience and knowledge. I would also like to thank all the participants who attend our event today. Your active participation and engagement throughout the session made the event more enjoyable and valuable. Your questions, comments, and insight have added depth and breadth to the discussion and have helped us to learn and grow. Finally, we would like to hear your feedback. Your input is valuable to us and it will be helpful to us to improve further webinars. Thank you all.